So let's start on section 10.4, and it has to do with slope and rate of change. So just a reminder, earlier I said if I have a point, and I'll put the point right here at the origin, and we noted that with a single point, if that's all we have, there's literally an infinite number of lines that can go through it. But notice these lines are distinguished by something we're going to call the slope. Right here, this is a horizontal line. It's also known as the x-axis. And as I move it slowly, the line slowly, counterclockwise, the steepness of the line gets larger and larger. In its value, it gets more and more steep until we hit a point where I have a vertical line. And we'll learn later on that the steepness of a vertical line is undefined. This concept of steepness is going to be called the slope of a line. And if we have a line, and here I've kind of recreated this, and this generic line that I have here actually goes through the origin. But it doesn't matter, it's just, it doesn't have to go through the origin. Clearly, a lot of lines do not. So if we have a line, and this is my line right here, that goes through the origin, and here I've actually placed 2 points on it, but we don't have to know the other point. I'm just defining a property given 2 points. So this distance right here, this vertical distance, we're going to call the rise, and this distance down here, which is x, is going to be called the run. So for any arbitrary line that I happen to draw, and I can add 2 points to it, and they can be literally anywhere. Here and here, for example, the ratio of the rise over the run is called the slope. So informally, and you may have heard this before, slope, and this is an aspect of a line, is the ratio of some magnitude that we determine to be the rise and some magnitude that we determine to be the run. Now, if our point on the line, or if the line goes to the origin, my values, if I know this point up here, the one I'm pointing to, then my y value is the rise and the x value is the run. But we have to have a general formula for a line, any line whatsoever, whether it goes through the origin or not. So let's look at this particular illustration I've got right here. Let me get another color that's close to yellow but not quite. So this point right here, it's going to have a direction, right? It's going to have an x value and a y value. Now, these aren't variables. These are actual values. And the reason I call it x sub 1 or y sub 1, or more generally x1, y1, is just to say this is a specific value of x and this is a specific value of y. They're constants. And up here at this point, whatever it is, it's also going to have a corresponding x2 and y2 value. These are constants. So by putting the subscript, I'm just letting you know that this is a fixed point. This is a fixed point. So the direction is fixed. So x1 and y1 are fixed. They're not variables. So with that in mind, I'm going to define a slope. So given two distinct, because you need two different points that lie on a line. I hope it's lie, maybe it's lay, on a line denoted by generically x sub 1, y sub 1, and x sub 2, y sub 2. Then the slope of the line get some more room here, provided x1 is not equal to x2. So that means the values of x1 and x2 have to be different, is given by slope is equal to y2, remember these are values, minus y1 over x2 minus x1. And the slope is often denoted by a specific variable, and that variable is m. Usually when we're talking about linear equations and we see the variable m denotes the slope. So this is the formula, and you will need to know this formula. We'll be using it quite a bit, and you'll see it again and again and again. So let's actually, before we do any problems, let's compute the slope. So I'm just going to make up 2 points. I'm going to say here we have a line, and one point on the line lies at 1 and 7, and another point on the same line is 10 and 3. So we're asked to find the slope of the line that passes through these 2 points. These 2 points are different points, so when I draw a line through them, I get a line with a certain slope. So how do we do it? Well, here is the formula. And it doesn't matter which one you choose, just choose one of them. It always comes out the same. And we're going to call this one x1 and y1. And the next one x2 and y2. So x1 is 1, y1 is 7, x2 is 10, y2 is 3. So the slope m is equal to y2 minus y1 over x2 minus x1. So that's equal to 3 minus 7 over 10 minus 1. So we see the slope is going to be a fractional value, but it could be an improper fraction. As a matter of fact, many times it will be. And that is equal to minus 4 over 9, which we can also write as minus 4/9. So that's a measure of slope. That is the slope. So actually, let's actually see what that slope would look like. So I'm jotting down the points. Let's go up to GeoGebra, and let me delete everything I've got here. And let's find the first point. X value is 1. Y value is 7. X value is 1. Y value is 7. Right there she is. The next point, my X value is 10. And my Y value is 3. So when I draw the line through those 2 points, that actually turns out to be the slope minus, what was it, minus 4/9, I believe. So as it turns out, that's true in general. Slope, if you want to think about this, if you were walking going from the left to the right, slope that makes you go downhill is going to be negative in value. On the other hand, slope that has you going uphill, like this line or this line, is positive, and a slope that is just level is 0. And it's going to turn out that the slope of vertical lines does not exist. It's undefined. So let's go and look and see what we're supposed to do. So the first thing we're going to do is exactly what I just did. We're going to find the slope that passes through 2 different points. So here I have point 1 is 6, 5, and point 2 is 1, 7. So choose one of them, and it doesn't matter which one you choose, to be x1, y1, and choose the other to be x2, y2. So the slope, m, is equal to y2 minus y1 over x2 minus x1, which is equal to 7 is my y2 value, 5 is my y1 value, and 1 is my x2 value, and 6 is my x1 value. So 7 minus 5 is 2, and 1 minus 6 is minus 5. So the slope will often be written as minus 2/5, where the minus is just in line with the division line. So let's do the next one. They want us to find the slope of the actual line. So we are given 2 points, and we have to find the coordinate values of the points. So here, this first point is minus 1, minus 2, minus 3. And we go down 1, 2. Minus 2, minus 3, minus 2. So that's going to be this point right here. Our next point, we have to get the coordinates. My x value is 1, positive 1. And now I'm going up on the y-axis in the positive direction. And I'm just going to assume that's going to go through 2. It's hard to really say. It doesn't look like it quite does, but that's okay. We're going to pretend it does. So if you think about what I said earlier, if we were walking up this way, we would be going uphill. So the slope here, m is always going to stand for the slope, should be greater than 0. That's another way of saying the slope should be positive. Well, let's calculate it. I'm going to write the formula down a few more times, and then I'm going to stop, because you should have it on your notes, or it should sink in at some point, but it must be memorized. It will be used in future classes. And here, just to mix things up, because it does not matter, I'm going to pretend this second one is x1 and this is y1, which makes this one be x2 and y2. Now you can always choose, if you write your points down side by side, you can always choose the first one to be x1, y1 and the second one be x2, y2, but the choice doesn't matter. So when humans are, in mathematics, when humans are given the ability to choose, mathematicians are very meticulous to prove that the results of the mathematical calculation do not depend upon the choice that humans might make. And that's the reason I did this one. So let's calculate the slope. The slope, m, is equal to my x2 value, which is minus 3, minus my, I said x2, I'm sorry, and I actually wrote it down. Glad I caught that really fast. Start it over, do it right. My slope n is my y2 value, which is minus 2, minus my y1 value, which is 2, over my x2 value, which is minus 3, minus my x1 value, which is 1. So minus 2 minus another 2 is minus 4. And minus 3 minus 1 is minus 4. So the slope is minus 4 divided by minus 4, which is equal to 1. Or if you prefer, 1 divided by 1. For every unit of rise, we have the exact same unit of run. So for those of you who are curious, it's not part of this class. This would rise up at a 45-degree angle. It's not part of this class. This is trig, and you're in an algebra class. So you might want to, just to check on your own, pause and do the following. I'm not going to. I want you to just believe me. But if you don't, make sure that you get the exact same number if you label minus 3 is x1 and minus 2 is y1 and 1 is x2 and 2 is y2. When you use the formula, you're still going to get the exact same thing. It doesn't matter. So again, this is just a lot of applications of the formula. We're given again 2 points, minus 5 and 0, and 0 and minus 3. And here for the last time, I'm going to write the equation for the slope, but I'm going to do something just a little bit different. The slope m is equal to and what I want to do is I want to write in the negative. This is subtraction here. And the reason I did it in a different color is that this is inherent in the formula. And we're going to see it this time. This is minus. It's always going to be minus. So if y1 is minus itself, it doesn't get to use this minus sign. It has to bring its own minus sign to the game. Down here, if x1 turns out to be minus, it has to bring its own minus sign to the game. It can't use this one. So let's calculate it. So I'm just going to go ahead and label them this way, and now I'm just going to use the calculation. So y2 is minus 3, minus 0, because that's 0 is y1. And x2 is 0 minus, and here we go, x1 is minus 5. It has to bring its own negative to the game. So minus 3 minus 0 is still minus 3. 0 minus a minus 5 is a plus 5. So the slope here is minus 3/5. So make sure whenever you have a formula in algebra that has a minus sign as part of the formula, that minus sign is inherent in the formula, and any other value, in this case x1 or y1, that is negative has to bring that negative with it. It can't use the one that's already there. So let's look some more at what we're supposed to do. So our next problem, so this is problem 2. This is 2a. So we want to find the slope of each line. So x plus y is equal to 12. Well, to find the slope, I need to find 2 points. Well, we need to find 2 points on this line then. But we have skills. We know how to do that. We just did it in section 10.3. Here's my x, and here's my y. And it's always a good way to start out by trying to find the intercepts, because it makes things easier if I can set one of my variables equal to 0. So when I set x is equal to 0, I get y is equal to 12. So I find the point 0, 12 immediately. Now I'm going to set y equal to 12. And that's just as easy. This is a good choice. You're seeing now why I did it. So x plus 0 is equal to 12 gives me the value of x equal to 12. So here are my 2 points. So the slope, if you want, I'm going to do it this way. I'm going to say this is x1, y1, and I'm going to say this is equal to x2, y2. So my slope m is equal to y2, which is 0, minus y1, which is 12, over x2, which is 12, minus x1, which is 0. So that gives me minus 12 divided by 12, which is equal to minus 1 over 1, which is just another way of saying minus 1. So now let's do problem B. You should maybe try to duplicate what we just did, because as it turns out, we will be able to make these types of questions easier, but we have to wait for the next section. One thing about developmental math is we try to be careful about giving you too much in one lesson. These are kind of baby bites. So again, here I've given the equation, so I have to find 2 points on that line. So this is an equation of a line. So when I graph this equation, it's going to be a line. So I have to find 2 points on that line. So again, I'm going to find the y and the x intercept. So I'm going to let x be equal to 0. And that's going to give me y is equal to 8. So there's 1 point. 0, 8. The next thing I'm going to do is I'm going to let y be equal to 0. Oh, wow. That's 3x. So that gives me 3x is equal to 8. So x is equal to 8 divided by 3. So now you're learning why we teach you how to use fractions. My slope m, and I will call this x1, y1. I will call this x2, y2. So my slope m is y2 minus y1, which is 0 minus 8, over x2 minus x1 over 8 thirds minus 0. So that's equal to minus 8 divided by 8 thirds. And you can't leave it that way. You have to simplify it. But remember, this right here, what I'm asking you to do, you say, oh no, what am I supposed to do? Just rewrite it. You're dividing. It's telling you to divide minus 8 divided by 8 thirds. And how did we learn how to do that? We make both of them fractions. And then I leave the first all by itself, as is, but I'm going to change the division sign into multiplication. And the price I have to pay is I have to write 8 thirds as its reciprocal, which means if it's negative, it stays negative. If it's positive, it stays positive. But the numerator and denominator flip. So this is equal to minus 8 times 3 divided by 8, which is the same as minus 8 times 3 divided by 8. Now my factors of 8 are going to cancel. And I'm left with a value of my slope equal to minus 3. So that's one way to do it. Another way we could have done it, notice that I chose my y value. I get to choose my y value, and I thought, okay, if I choose my y value to be equal to 0, it's going to make things easier. But literally, if I would have chosen my y to be 2 rather than 0, it would have been easier. So let's go ahead and do that. So this is just, again, not the eraser I wanted. Let's go ahead and choose another value. I'm going to choose my y value to be equal to 2. And you're going to see that makes things easier. Then I have 3x plus 2 is equal to 8. So I'm going to solve this by moving the plus 2 to the other side, and it becomes minus 2. So I get 3x is equal to 6. So if I divide both sides by 3, I get x is equal to 2. Now, if the point 2, 2 is chosen to be x2, y2, I can calculate the slope, m, to be 2 minus 8 over 2 minus 0, which is minus 6 over 2, which is minus 3. And that's what we got earlier. So it doesn't matter. We get the same answer. And in this case, I was able to make my math easier by kind of looking over here at the algebra, realizing if I subtract something from 8 that makes it divisible by 3, then when I divide it by 3, I'll have a whole number. And the easiest choice out of an infinite number of choices was subtract 2 from 8. So by making y 2, then when I move it over, I subtract it and I get it. So that's just using algebra on algebra. So let's go ahead and do the next problem. Let's move it up here. So we're finding the slopes of a lot of lines. So the only way we can do it right now is to find 2 points that lie on the line. And we've been doing that an awful lot. So this is 1C. So we have 11x minus 3y is equal to 33. And I can see setting y equals to 0 will be absolutely fine. So I'm definitely going to do that. And setting x equal to 0 will also be fine. So let's find our y-intercept and then our x-intercept. So I'm going to set x equal to 0. So that's 11 times 0 minus 3y is equal to 33. But 11 times 0 is 0. So it boils down to minus 3y is equal to 33. So again, I'm going to divide both sides by minus 3. Now we get a value of y equals to minus 11. So right there is 1 point. 0 minus 11. The next thing I'm going to do is set y equal to 0. So when I set y equals to 0, I have 11x minus 3 times 0 is equal to 33. So that gives me 11x, because minus 3 times 0 is 0, is equal to 33. And now I'm going to divide both sides through by 11. And that gives me x is equal to 33 divided by 11, which is equal to 3. So here is another point. And here I'm going to teach you another way of doing this. Here I have my 2 points stacked on top of each other's. If this is my x and these are my y's. So what I'm literally going to do here is the following. It's another way to do this. Minus 11 minus 0. So I just take the top value, subtract the second value from the top value, and then I go to the bottom and I go 0 minus 3. And that gives me minus 11 over minus 3. And that gives me a negative divided by a negative is a positive. So my slope is 11 over 3. That's going to be the exact same thing if I call the top x2, y2, and the bottom x1, y1, then y2 minus y1 is just subtracting 0 from minus 11 over x2 minus x1 is subtracting 3 from 0. And that's what I did right here. And the result was the same. So I kind of like this stack on top of each other. That method works. But remember, this is always the formula right here. This is my slope m. M stands for slope. Let's do another one. This is 1d. 9x plus y is equal to minus 12. And remember, you can choose any value for x. You could literally choose 2 different values of x if you want to. Let's actually do this. Let's choose a value of x to be equal to 0 and a value of y to be equal to 6. You don't have to do it kitty corner. There's no reason, so I'm doing it a different way. So here, my first value of x is 0. So that gives me my 9 times 0 plus y is equal to minus 12. I'm going to change that value to 6, by the way. So that gives me y is equal to minus 12. Let's make this easier. Change it to a smaller value. If I were to let y, let's just do this. Let's let y be, doesn't matter. Let's let x be 2. I don't want the numbers to get really, really big. And when I said let x be 6, I was actually thinking let y be 6, and that would have been fine. All I'm stressing here is when you have a choice, make the best of it. And you could easily choose 0 for x and 0 for y like we've been doing all along. But I just wanted to show you, you don't have to do that. You could choose a value for 2 different values of x. It doesn't even have to be 0. Or you could choose 2 different values of y and find the corresponding values of x. But here I've chosen x to be 2. So that's 9. Plus y is equal to minus 12. So 9 times 2 is 18 plus y is equal to minus 12. So I'm going to move this 18 to the other side. I get y is equal to minus 12 minus 18. So y is equal to minus 30. So I have 2 points, 0 minus 12 and 2 minus 30. So let's use the stacked up method to calculate my slope. So minus 12, and I subtract from minus 12 minus 30. Then I have 0, and I subtract from 0, 2. So I have to simplify. This is equal to minus 12 plus 30 over minus 2, which is equal to 18 over minus 2. And 18 divided by minus 2 is equal to minus 9. And if you want, you can put that as minus 9 over 1, which means for every 9 units of rise, there's 1 unit of run. So we'd have 1 unit of run. This is 1, and then I would come up 9. And this is not to scale, but I'll try to make it a little bit more to scale. Nine. So this is my rise. This is my run. And my slope is the line would be the hypotenuse of this triangle, more or less. The slope would look more or less like that. Pretty steep. Go on to the next one. Okay. Now this stuff down here, it says when we're going to determine whether the lines are parallel and perpendicular. That's not part of what we do in this particular class. It is, perhaps if I were seeing you in real life and I could gauge how well you were doing, I might decide to cover it anyway, because it's something you will encounter when you get to intermediate algebra. So here, we're going to discover something. I'm going to have, this is 3a. This is going to be easy to find 2 points, right? X is equal to 8. You should be able to tell me right now what type of a line this is. Whatever the case, x has to be equal to 8. So I'm going to say let's let y be equal to 8 and 0 here. So I have the point 8, 8 and 8, 0. Those are 2 points that lie on the line. Now some of you may have remembered the definition I gave of slope, but we're actually you're going to see now exactly what I said there. So we're going to call this x2, y2, and we're going to call this x1, y1. And slope is equal to y2 minus y1 over x2 minus x1. So in that case, that's equal to 8 minus 0 over 8 minus 8. So that gives me 8 over 0. What on earth? Gasp. This is an undefined number because I have division by 0. So what that tells us is the following fact. If you look back at the very beginning of this video, when I define the slope, I say that the values of x1 and x2 have to be different. They cannot be the same. So here is the takeaway, really important takeaway. The slope of vertical lines is undefined. Why? Because it leads to division up by 0. So now we're ready for the last problem. I'm going to have to look ahead. This may be a short lecture. Oh, we have 2. So we'll actually do all of these. They won't be very difficult. So this is 3b. So I have y plus 5 is equal to 0. Notice there's not an x in the equation. So we want to solve for y. So that gives me y is equal to minus 5. So that is indeed a line. Let's find 2 points on it, but it's going to be really easy because y is minus 5. It's a constant. So I can choose anything I want for the x value. So here are my 2 points. Why did I choose 5? No reason. I just did. And let's find the slope now. Now you might actually be anticipating what it's going to be by what I said earlier. So I'm going to call this x2, y2, x1, y1. So my slope is y2 minus y1. So that's minus 5 minus, remember the minus is inherent, and this being negative has to bring its own negative along. And then x2, which is 5, minus x1, which is 0. So this is the same thing as minus 5. Minus a minus is plus. And this is 5. So simplifying more, minus 5 plus 5 is 0. 0 divided by 5 is okay. 0 in the numerator always gives 0. So again, just to remind you, 0 divided by 5 is the same thing as 0 times 1/5. And 0 times any number is equal to 0. So my slope is 0. So that leads us to another observation, which I will write here. The slope of horizontal lines is 0. Something you need to know. It's an absolute necessity. And the last problem, I believe. No, well, we're going to do one more. I've got to talk about grade, so there's one on the next page. Is number C, but it'll be really fast. Because now we have the required definitions to help us out. So 3C gives us 2x minus 7 is equal to 0. Notice there's no y in here, so we solve for x. So when there's only a single variable, whether it's x or y, then we solve for that variable. In this case, we solve for x. So that gives me 2x. I move the minus 7 over, and it becomes plus 7. And then I divide both sides by 2. So x is equal to 7 halves. And again, you should know that this denotes a vertical line. And I'm not going to do anything else. Hence, the slope is undefined. Okay. So the parallel and perpendicular lines, that's really, really interesting. But again, it's not something that we're going to deal with in this class. And it reminds me, I need to make sure your homework doesn't have any of those types of questions on it. I'm pretty sure it doesn't. So if any of you have done any traveling and living in Florida, it's probably through the Appalachian Mountains. But if you've ever gone out west and you've crossed the Rockies, you will see all of these warnings to the truckers saying that the grade of the following road is a percentage. So the grade is equal to the rise over the run times 100. And the grade is given as a percent. So in other words, you will see warning truckers, downhill grade 6%. So what type of a slope is that? Well, 6% is 6 over 100, which is the same as 3 over 50. So for every feet it declines, in this case, I don't think they ever give the negative there. If it's downhill, it's a negative slope. If it's uphill, it's a positive. But it's for every 53 we've descended 3. So let's look over here. 350. So the ratio is horizontal distance to vertical distance. So I would have 50 feet here and then 3 feet here. So well, that doesn't seem too much to you, but you get a semi going down through there and it gets out of control, you're messed up. So let's go ahead and use this, especially if they don't know how to engine brake. An inclined ramp leading to a warehouse. So here's our warehouse. I remember as a kid, we literally, before shopping malls existed and we went to the local town square, there's a store called Gibson's. It had this huge ramp, wooden ramp, out to the back parking lot. As kids, we loved that ramp. We loved going there. That was the warehouse. I think it is still there, although it's probably been shut down. So an inclined ramp leading to a warehouse is to rise 16 inches for each horizontal distance of 17 feet. So this is inches and this is feet. So this is not going to work. We have to find the grade. But to find the grade first, we have to find the slope, and then we multiply it by 100 to get it into a percentage. So I'm going to go ahead and leave 16 inches as inches, but I need to convert 17 feet as inches. But for every 1 foot, we get 12 inches. So 17 times 12 is equal to, did I do this one? Oh my goodness, I'm embarrassed. I'm looking at my answers for this one and I didn't even notice that this was in feet and this one is in inches. I just did 16 divided by 17. So let's do this. 17 times 12. I don't know what that is. 2 times 7 is 14. So it's 204 is equal to 204 inches. So our rise over our run times 100 is equal to our grade. Go ahead and remove my calculations over here. Need to take a note. I think I normally catch this when I teach it in class when I was doing my notes previously. So my rise is, the point is everything has to be in the same unit. And now my is equal to 16 inches over just 204 inches. And I'm going to multiply that by 100. So that's going to be equal to 1600 divided by 204. And that's going to reduce down. But I'll let you all do that. I kind of want to see what it is in decimal. So I'm going to launch a calculator here. I'm going to cheat because I'm just being lazy. I'm going to just go over to the basic mode. I'm going to do 1600 divided by 204. And remember, because I multiplied it by 100, it's going to give me a percentage, and that percentage was 7.84.6. 7.84% grade. Okay. I don't know, there could be some grade questions on your homework, but just remember, whatever we're doing, if our units are rise over run, they have to be converted to the same unit. And once we do so, the end result is just a pure number. I could have equally turned 16 inches is equal to 1 foot and 4/12 inches, which is equal to 1 inch and 1/3, which is equal to 1.33 forever feet, and then just did 1.33 over 17, and we'll get the same result, as you can see here. We get the same pure number, and I have to multiply that times 100, and I get 7.82. Of course, why is it a little bit different? It's 1.33333, and I just rounded it off at 1.33. So that's it for now. The next lecture is going to be a special type of equation that allows us to calculate slope literally by doing transformations, algebraic transformations to the equation in two variables itself, and it's called the slope-intercept form of an equation, and it's just a beautiful way to do things.